Let me continue. This is chapter 4, part 4. Chapter 4, part 4. We're talking about logical operators right now, and you look at the operators, how it's being evaluated. Remember the associative rules that you start from the left to the right with this thing? So you look at how you evaluate these data. It's very important with this. But I'm going to come down here to this expression right here. We have count is greater than or equal to 0, and count is less than or equal to 100 with this one. Well, if you take a look at count, this is very important. Count is, first, this is, in order for this expression, this is an and to be true. Both of these expressions needs to be true and true with it. Okay, so that's how you actually assign both of them needs to be true. That actually takes place in the outcome to be true with it. Now, count is 20. Let's say you plug in 20 in this case that they're saying. So 20 is greater than 0. It's true. And count is less than or equal to 100. Both of that is also true as well. So you have true and true. Outcome is true. Okay, this is what this is saying. It's pretty self-explanatory. So I like I said, I go through here, and you can go through a lot of these expressions, and you can see what's going on with it. In the earlier version of C++, did not provide a built-in data type that has Boolean values. Logical expression evaluates either to ones or zeros. Logical expression stores a variable of the data type int. Can use as an int type to manipulate the logical operators with it as well. So this is just a data type of an integer that you can actually evaluate to either a false or true with it. Boolean data types has logical values as true, false. So you have things such as Boolean, a true and a false are reserved words. Okay, Boolean. So identifiers such as true has a value of 1, false has a value of 0 with this. So you look at, for example, here's our first structure for the selection with it, if and if else. An if and if else statement can be used to create one-way selection or two-way selection or multiple selections with it. A one-way selection is normally being used as if. A two-way selection is if else, and a multiple selection is nesting the multiple if else in there. Okay, so let's take a look at this. Here's the first one way. If the expression is true, then you're going to do this. This is what this is saying. Okay, this is what the expression. You can also think about the expression. Kind of think of it as a decision maker. Okay, this is kind of like a decision maker with this thing. Coming over down here to the next one, if you take a look at, here is the flow chart of this thing. It's a simple true or false with this thing. Very, very simple type of one-way selection with it. Here's a two-way selection. You have an if-else. It's just a two-way. And you could do this. The statement one only executes if the expression is true. If the expression is false, it goes directly to the statement 2. Another way how to depict a flowchart of this is expression true and false comes to two statements and ends in the same place with this. A compound block statement. You're going to hear this over and over in multiple places that people talk about, is you can actually put in compound block statements with this thing. So you can put in a curly brackets to block a certain condition inside of a function. For example, you're familiar with an int main function, and inside of that has the curly brackets, the left curly brackets and the right curly brackets for the same. Okay. So here we go. For example, here's a compound. Here's a compound. That's my wife coughing over there. Excuse her. Here's a compound statement over there. If age is greater than 18, then you will execute this. Well, when do you actually use this? Well, anytime when you use a compound block statement, you have multiple statements that you are giving instructions to, multiple tasks that you break this down to. So, for example, if I just have a cout eligible for it to vote in line, this one line, I don't need a compound curly brackets. But if I have multiple line of instructions like I have right here, I need to put a compound statement to give it a block instruction. Nesting, one control statement located within another. So if you have a nesting statement, you can nest one inside of another condition. So let's say, for example, I'm looking for a male above the age of 18 that wears glasses. These are the two conditions. I can have an if statement, if male or true, nest that into another statement, wears glasses, if that's true, then I would actually have another conditions with it. You gotta be careful in nesting. Nesting is very difficult with maintaining the code. 80% of a programmer's life is maintaining other people's code. The moment you do that, you start to nest in multiple nesting. It's becoming very difficult to maintain the code. So that's why you have logical operators to remedy this. Okay, so we're going to look at some of this discussion in a few more minutes with this. So let's take a look at this. This is if you have a multiple nested statement, if you have a range, this is a range, and you're familiar with the range and the grading scale. If you earn something above a 90, you get an A. And this is a breakdown of the range with it. So why don't I pause right here